Hi, I'm Mark Weitzman, and this video I'm doing a screencast solving some of the problems in Homework 0, Probability and Linear Algebra Review for MITx 18.6501x Fundamental of Statistics for the fall of 2019. As some of you may know, I was a CTA for the prior version of Fundamentals of Statistics. And I've also been staff on many of the quantum mechanics courses by MITx. And Maple is a mathematical software. There are many statistical packages and programs you can use to do statistics, but Maple and Mathematica, and to a much lesser extent MATLAB, have symbolic capabilities. And they let you do all kinds of general math, not just statistics, but like theoretical physics and engineering and everything. And this type of software has become indispensable for many professionals. And Maple is one of the better ones in my opinion. It has a very shallow learning curve. It has textbook quality appearance in its output and its input, as you'll see. And you can get a student edition for like less than $100, and taking this MOOC course will qualify you. All you have to do is call them up and tell them you're taking this course and you'd like to purchase a student edition. And it's a full-featured edition, and it comes with, I believe, an unlimited license. So you can't use it in your commercial work, but it's for students. It's just excellent. It saved me thousands of hours over the years in mathematics and theoretical physics. So I want to begin with the homework problems, and the first one on Gaussian random variables calculating these moments gave some students problems. You can look at the solution. It's not really that hard to do and everything analytically, but I just want to show you how you can do a lot of these problems without thinking, just by using this software. The software sort of does the thinking for you, which is why you really shouldn't use software unless you know how to do the problems manually. Unless you have a good understanding of exactly what's going on, you'll tend to make mistakes. And you know the old saying, garbage in, garbage out. So let me start with this. The first thing I'm going to do is Maple has a statistics package with a lot of functions and everything. And you know, there you can see all the functions that are accessible, and I can suppress the output so we don't have to look at all of that right now. But I'm going to define a Gaussian random normal variable, and the first thing I'm going to do is sometimes it helps to always tell Maple the values, you know, of these variables. So I just have it assumed. And one thing I like about Maple is it has these palettes which are attached to the main program. And I tend to use letters and notation that are sort of standard rather than spelling things out like SIGMA and everything. So I'm now going to define a Gaussian random variable. And the command is and I don't usually remember all these commands, but you can get them very easily from the help menu. And right now, like if you didn't use the help menu, you wouldn't know this, but as was warned in class, everybody uses a different convention. Maple uses the convention, oh, I don't really need to see that. Maple uses the convention of using the standard deviation, not sigma squared, as their parameter for the normal distribution. So that's a little bit different. You have to be careful there. So let's just calculate like the expected value of x squared. I'll define it as ex2, and we'll just use the definition. The definition of any expected value is we integrate the probability distribution over its whole range. X squared, the function we want the moment of, Now, if you notice, I don't have to type out the whole, I've defined this as a normal random variable, so I don't have to type out the whole 1 over the square root of 2 pi e to the minus x minus u squared over 2 sigma squared. It knows it from the PDF of capital X. So let's just hit return and see what it evaluates. Mu squared plus sigma squared, same as there. Okay, let's go on to EX3. And you don't have to assign these things to variables, but sometimes it helps, because if you want to use them again, you just refer to the variable. Okay, that checks out. Let's do the fourth moment. Now, some people prefer using commands. I prefer using palettes and not filling my brain with commands. So, you know, these commands would be like int and this and that, but I just prefer using the palettes. Okay, that agrees. Let's calculate the variance. Nope, I don't need to do any calculations on this one. It's just EX4. Definition of variance. When you take the variance of a variable, it's the expectation of that squared. So that would be the expectation of x to the fourth, which we've already calculated, minus the mean of this, which we've already calculated here, squared. Okay. Now this is the right answer, but it didn't simplify it. Sometimes it helps. If you want to always get simplified answers, just put the simplify there first. Now we get the same thing. And of course, the advantage of computer algebra systems, of course, is if you do calculations that you couldn't do by hand, or you wouldn't want to. Not that you'd ever need to do this one, but let's just see what it gives. The 100th moment of a Gaussian. Okay, there it is. The whole in all its glory. That's why. Okay. Now, the next thing I want to do is go to the next page, and we have some things with uniform random variables. So we can define the same thing. Let's have u as being a random variable, and it has about 40 different types of random variables in the statistics package. And then I have the same definition for v, so I'll just see if I can cut and paste it. Okay, so first one I want to do here is I want to do this one, this problem here. So let's calculate the expected value of the absolute value of u minus v. Now, it's an interesting way to do this. we can just do a double integral. Again, let's just define everything the way it is. 0 to 1, 0 to 1. I have the PDF U comma U, let's call it, and I have times PDF V comma U, and now what I'm going to do is I'm just going to multiply. This is a definition of expectation. So, oops. So I'm going to multiply that by the absolute value U minus V. Tab V tab U. Doesn't really matter which way we need it. Okay, so it gives us 1/3, which is the correct answer. And then I'm not going to bother with this one, but let's just see how we calculate this. This looks a little bit harder because this isn't really a mathematical function, it's a set. But we can turn it into a mathematical function. So let's do it again. Should have just copied. Okay. Okay, I made a mistake there. Now here, this is like an indicator function, and there's a function in Maple which functions very much like an indicator function. It's called, some of you may be aware of it, it's called the Heaviside step function. And what we're going to put for here is we're going to put, basically, this is 1 whenever U is less than V, or it's 1 whenever V minus U is greater than 0. That's exactly what the Heaviside function does. This has the value of 1 when this argument is positive, and it has the value of 0 when it's negative. So it's just like an indicator function. The value at 0 isn't relevant because we're working with continuous quantities, and one variable doesn't matter. So let's see what we get. We get a half, just like that. By the way, one didn't need to do any computation to answer this. U and V, there's no difference between U and V, so obviously the probability that U is less than or equal to V is the same as the probability that V is less than or equal to U, so it can only be a half. Okay. Alright, I now want to look at the, go to the next page, and I want the one after that. Okay, Gaussian probabilities. So let's just show how, we can just also do numerical calculations just as easily. So here we have X is a random variable, so, and you can reuse your variables every time you assign it. Like here it's this, but now I'm reassigning it. And we have a normal random variable with a mean of 1, and sigma squared is 2.25. We need to put in sigma, so we need the square root of that. Okay. Now the first problem is the probability that X is greater than 1. Again, you don't need to do any calculation here because this is mean is 1, so it's going to be 1/2. So let me go on to the next one. Probability the absolute value of X minus 2 is less than or equal to 1. There's several ways to do this, but let's say you don't want to think. You can do the same trick we did last time. Integrate over the whole PDF. use that heaviside, or basically what's an indicator random variable. What happened there? 1 minus the abs, sorry. Okay, so again here, this thing is a set, and we want to know when this set is, when this condition holds, then 1 minus the absolute value x minus 2 is positive. So that's the same thing. And we get this number, and that number works. Then the same thing with the next one. Here we want to do x squared minus 4. Now it's probability x squared is greater than 4, so this is basically same as x squared minus 4. Oops, sorry. When that's greater than 0. And we get this number, which is correct. And then finally, let's do the last one here. And this time it's just x, it has it written as we want it even written, so I don't even have to do anything. X squared minus 2x minus 1. And that's correct. Now, these problems are fairly easy to solve manually, but imagine someone gave you something like this. Asked you to solve it when x to the 7th minus 5x to the 4th minus 3x plus 1 is greater than 0. There's just no way, you can't even solve these type of equations. There's no way to do it without, oops. Okay, I meant to just say that. So this doesn't seem right. I know I can't get a negative answer. Why do I get a negative answer? Very strange. That's reasonable. I just don't know why I got a negative answer before, but I'll have to investigate that. But anyway, you can do things that you could never do manually because you couldn't solve this. Okay. Let's do the next one. So as I said, we have all kinds of variables here. Again, when we approximate the binomial variable, we're going to use a normal probability table and everything, and there's a standard way to do this, and that's the way you should do it. But I just want to show that you can do it by brute force in Maple. So let's define a binomial variable. The same parameters that we're given. And then, so we want the probability that x is, I defined it as w here, but x is greater than 400, so we can just literally sum all the probabilities. sum from, let's go, I equal 401 to 1000. And for discrete variables, we don't have a PBF, we just have a probability function. And there's the answer. I just inputted 0. I knew it was about 0. Okay. So now I want to go to an area where all these programs are like very good is linear algebra. And for the problems we have here, they're so trivial you would never, it takes you longer to enter the stuff. But I just want to show you that I can do it. And once again, you have all these functions in the linear algebra that are accessible to you. And so let's do like, go to the next one. So let's just do these things, vector inner product here, okay? So there's many different ways of doing matrices and vectors in Maple, but I like to just not even think, and there's this palette here. So I'm going to enter a, these are 2 by 1, so rows 2, columns 1. I'm going to say U, I'm going to assign to U, and then I just fill in the numbers, 1, tab 3. Okay, so that's U. I'm going to do V. V is -1, 1. Okay. Now, to do the inner product, Maple sort of knows how to do it. Oftentimes, the operation for multiplying matrices or vectors or whatever in Maple is a dot. So you don't use the multiplication sign, you just use a period. So U dot V gives you the answer too. Sometimes you're a little concerned, you're saying, well, I'm multiplying a 2 by 1 by a 2 by 1, and that really doesn't work out, but Maple just automatically does it correctly. You can also do like U percentage transpose. Oops, sorry. I did that wrong. This is a little funny notation. I don't know why they just don't have U wedge T, but they don't. Dot V. So this is another way, like U transpose. This is the transpose of U multiplied by V. And you can actually use the actual transpose command. And or you can just use the dot product command. So whichever one you remember. And now for the vector outer product, here you just go, I'm not sure this is going to work. This might give me the inner product here. Let me see what happens if I go U dot V. Yeah, that will give you the inner product again. I can't do that. But if I go U dot V transpose, it should work. Right, so that's the outer product matrix. Or they have a command. Outer product matrix gives you the same thing. And now, so I think, let me go to the next one. We'll go to rank and some of these other linear algebra things. So let's assign a matrix A. Let me do it. This is a 2 by 2 matrix. And if you want the rank, you just go. There it is. And so just to show you all these examples that they have here, I'll just, rank. Does them all. Make sure it does the edge cases right. So gives you all the answers. And then for this exercise, again, by the way, if you see this local D here, it means that D is a symbol that's protected by Maple. Normally it uses this for a differential operator. So for me to use the symbol capital D, I have to make it local. That's all that's involved here. But then, I can just do the ranks. Of course, you should read what it said in the problem to expand them as, outer products, and in that way do it. But we're sort of doing things without thinking here. And so the next thing on, let's see, when we get to like invertibility of a matrix. So these are all our matrices. Now you can simply test the rank on each one. So the rank of A is 1. It has to be full rank, which would be 2, in order for it to be invertible. And you could even test it, because matrix will, to take the inverse of a matrix, you just A inverse, and it tells you error singular matrix. So that tells you that that is singular. On the other hand, B is not singular. And if I were to do the same thing with B, that's the inverse of B. You can check and multiply it out. So let's just do the other two here. Ranks. Oops. So I didn't define the small c. Rank C. Just to verify it, take the inverse. There's your inverse. And then rank D. Okay, and so in the case of eigenvalues and eigenvectors, of course, it has its own command. So if this is the matrix A, and if you just wanted the eigenvalues, you just go eigenvalues of A, and it will give it to you as a row vector. Sometimes you want the eigenvectors along with the eigenvalues. So you can do eigenvectors A, and it will give you both. The first output will be the list of eigenvalues, and then the corresponding rows are the eigenvectors. And if you want the determinant of A, six, the trace of A, five. So I just want to show you a little bit of what Maple can do, and now I'll show you like the help package. This is the help menu, and some programs like Mathematica have it all online and everything, but I actually prefer this locally. But if you just go to the table of contents, you can either search or go to the table of contents, and you see it has a whole like physics package and all these commands on theoretical physics and everything, and tensors and non-commutative geometry and everything. So really advanced theoretical physics package. Then statistics, it has this whole statistics package, and it has example worksheets, and even if you don't know how to use it, you can go to like an overview. You can see it has all these probability distributions, and then like you just click on one and it will go and tell you, here's how to use it, calling, then examples. It always has a lot of examples and everything. And so it has all these things I'm not even that familiar with to do smoothing and estimation and everything. So all kinds of statistics problems. we'll learn in this course things like the Fisher information, the likelihood, maximum likelihood estimates, quantiles. You can see there's all kinds of things on quantiles, and regression, simulations, and visualization. It does all these graphs and everything. So I've only touched a little bit on what Maple is capable of doing. Like if you look at the mathematics, it's got like every subject area, and it's got tutorials on all these areas and everything. So for $100, you'll get your value, and it's something I think anybody who's serious and is going to use in their life mathematics, anybody who's going to be an engineer or a physicist or other scientist, you're going to have to use some software. For me, Maple is what I prefer, but there are others like Mathematica and MATLAB. There are open source ones like Sage. Python has a lot of symbolic manipulation package. But in terms of ease of use and everything, I really like Maple. So that will be the end of this screencast, and I'll try and do one on every problem set if there are problems that I think can be solved easily with software. Thank you very much.